The second method is what we call Cramer's rule. And this rule states that we can take each unknown in a system of linear equations and express them as a fraction of two determinants. So we're going to talk about the denominator as one determinant, and that denominator is going to be formed by the same A matrix we just talked about, and we're going to have a numerator. This numerator is going to look a lot like the coefficient matrix of A, but it's going to have a little bit of a change in there. We're going to start with a copy of A and then replace one of the columns to make this new matrix. So let's go to A times X equals B again. We'll pull out our coefficients for different matrices just as we did with the previous example. Now then, we're going to define the determinant as simply just that A matrix, the coefficients. So how do we go about getting values of X? Okay, we're going to have to look for patterns here. But essentially we're taking the B matrix and we superimpose it on the first column of the A matrix to get X. We superimpose it on the second column of the A matrix to get the second variable, I'll call it Y or X2. And we superimpose it on the third column to get, I'll call it Z or X3. Then we simply take determinants of each of those matrices, divide through, and we have our solution. Using Cramer's rule actually works pretty slick if you're doing two equations and two unknowns. We'll go through an example of that in class on the board. If it gets much more than that, three equations and three unknowns, it's fairly easy to do by computer. But if it gets beyond that, I'd recommend another method. Either use the matrix inversion method or a different solution provided by one of the math packages.